All right, we've already done one exponential example of the method of undetermined coefficients, but let's actually look at this one because this one's going to be interesting. Okay, so we go as usual. We're going to do our general homogeneous solution. So here's the homogeneous version of the differential equation, and characteristic equation is r squared minus 10r plus 25 equals 0. So we factor that as a perfect square, actually, which means it's a repeated root. We can directly write the solution, but we're going to need a slightly different term than if it were not a repeated root, so we need a t here, and we put the same exponent, the root of 5, onto the t. Okay. Now, if we were to guess a solution for the particular solution for the non-homogeneous version, normally we would guess y equals a times e to the 5t, because when we take derivatives of e to the 5t, we get the same thing. Let's just try that. So we're going to take a derivative. We get 5a e to the 5t, and a second derivative, we get 25a e to the 5t, and then we're going to plug it in. So what's the original differential equation? Y double prime minus 10y prime plus 25y, right? So let's put that in. Y double prime is 25a e to the 5t minus 10 times this one is 50a e to the 5t plus 25 times that one is 25a e to the 5t. And what happens? I have 25 minus 50 plus 25 is 0, which is never going to be e to the 5t. Okay, so what happened here? Well, my guess for my non-homogeneous differential equation was actually a solution to the homogeneous differential equation, right? Because remember, we got these solutions by saying each of these is a solution, and then we can take linear combinations of them. That was from about a week ago. So it can't be a solution to this one and also a solution to this one, because e to the 5t is not equal to 0. That was the exact problem. Okay, so what do? Well, we guess again. Once we know the answer, we won't have to guess this many times. Okay, so what happens? What if we multiply by t? What is that going to do? Well, when we take derivatives, so we get the product rule, and some stuff is going to cancel out. Let's just see what happens here with this guess. Okay, so we get y prime, and we're hoping to be able to solve for a here. So we take the product rule. So a derivative of t is 1 e to the 5t, plus there's also an a here, t, and then derivative of e to the 5t is 5 e to the 5t. Okay, and then second derivative is 5a e to the 5t for this term, and then we need a product rule here. So plus 5a derivative of t is 1 e to the 5t, plus, and then derivative of e to the 5t, I get another 5, so 25a t e to the 5t. Okay, and then we're going to plug it in again. So y double prime minus 10y prime plus 25y equals, y double prime is all of this. Can I combine anything? Yes, this is a total of 10a e to the 5t plus 25a t e to the 5t minus 10 times y prime, so 10a e to the 5t minus 50a t e to the 5t plus 25 times y plus 25a t e to the 5t. Let's see what happens. And this is supposed to equal the original, right? E to the 5t. Okay, let's see what happens on the left. So we have the ones without the t's, so just a e to the 5t's. We got 10 of them. We're subtracting 10 of them, and that's it. So that's 0. And then the ones with t's, we have 25 minus 50 plus 25. That's 0. So actually, this thing is 0 again, which is not the same as e to the 5t. Okay, so we've tried twice, and it hasn't worked. Is it always just going to cancel out? Let's think about what happened. Why did this still cancel out? Well, the t terms just came from the second part of the product rule every time. And so these coefficients, the 25 minus 50 plus 25, were actually the same as here. So that's why those canceled out. Why did these other ones cancel out? Well, this was, now we started here, and then this was the same thing that was going on up here when we took derivatives. So that's why this canceled. And actually, in general, why this didn't work was this solution, at e to the 5t, was still a solution to the general, to the homogeneous version of the differential equation. So of course, when we plugged it in, we got 0, because that's what it means to be a solution to the homogeneous differential equation. Okay, so let's keep going. We're running out of terms of the homogeneous one, right? We can't guess another one and still be a solution up here. So we're almost there. So this is going to be the correct guess. We're going to put in one more t. So t is fixed things. If your guess doesn't work, multiply by t, basically, the approach here. This is going to be pretty ugly. We're going to have a lot of product rule, but it's going to work. So derivative. Derivative of t squared is 2t. So 2at e to the 5t plus, and then derivative of e to the 5t is 5 e to the 5t. So we got this here. Okay, that was one product rule. And then y double prime is going to have two different product rules. Derivative of t is just 1. So 2a e to the 5t plus derivative of e to the 5t is 5 e to the 5t. So we have a total of 10a t e to the 5t. Plus derivative of t squared is 2t times 5 is 10a t e to the 5t plus derivative of e to the 5t is 5 e to the 5t. So I have a total of 25 a t squared e to the 5t. And for convenience, we'll just combine those, simplify as we go so that our life is easier later. So this is a total of 20a t e to the 5t plus, and then we have 25 here, 25a t squared e to the 5t. Okay. Now, what is the original differential equation again? We have it here, y double prime minus 10y prime plus 25y, right? Y double prime minus 10y prime plus 25y. Okay, we write y double prime as is, 2a e to the 5t plus 20a t e to the 5t plus 25a t squared e to the 5t minus 10y prime, so 10 of these, minus, that's a 20a t e to the 5t minus 50a t squared e to the 5t, and then plus 25 of these, plus 25a t squared e to the 5t. And what's that supposed to equal? It's supposed to equal e to the 5t. Okay, let's combine some terms. So we've got t squares, we've got t's, and we've got constants. So let's look at the t squares. 25 minus 50 plus 25. Okay, the same thing going on. Those are going to cancel. And then what about the t's? We've got 20 minus 20. Those are going to cancel. But finally, we have something that doesn't cancel. So we don't have 0 on the left. So we get 2a e to the 5t equals e to the 5t. And actually, okay, this is easy now. This has to be equal for all values of t. So that means the coefficients have to be the same. 2a equals 1. A is 1/2. Okay, so after all that work, the particular solution to the non-homogeneous differential equation was 1/2 t squared e to the 5t. And then combine that with our general solution to the homogeneous equation, we get our general solution to the non-homogeneous differential equation. I'm copying from the other page. Y is c1 e to the 5t plus c2 t e to the 5t plus this one, which is 1/2 t squared e to the 5t. Okay, so obviously now that we know what's going to happen when we solve it, you don't have to do all these wrong guesses. You're going to make your guess, And then if it's already a solution to the homogeneous differential equation, you know it's not going to work. You keep multiplying by t's until it's not a solution. So here the lowest power of t we could do was t squared. And then we can solve for a as usual, and that works.